All right, so let's start off with the e to the x. We know that e to the x is, and let's just write it out. They only want the first four terms here. So e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial, etc. So what would e to the minus x be? So we need e to the minus x. So all I need to do is everywhere I see an x in my expression for e to the x is either literally or in my mind's eye replace the x with the quantity the opposite of x. So this would be 1 plus the opposite of x plus the opposite of x squared over 2 plus the opposite of x cubed over 6 plus the opposite of x to the fourth over 24, and so on. And remember, odd powers are going to keep the negative. The even powers will absorb it. So on. So before we go any further, is everyone okay with how we're getting this expansion for e to the minus x from e to the x? Let me know if that's okay. All right. So now I want to do the same thing. And now what do I need to get? I need the cosine of 4x. So I'm going to start off with my series for cosine. Whoops. And once again, they're just asking for the first four non-zero terms, so I'm just going to write out the first few terms here. Now remember, cosine is an alternating series. Cosine is an even function. It's the even powers over the even factorials. So it's 1 minus x squared over 2 factorial, which is 2, plus x to the fourth over 4 factorial, which is 24, minus x to the 6th over 6 factorial, that's 720, and so on. So to get to the cosine of 4x, I either need to literally or in my mind's eye replace each value of x with the quantity 4x. Whoops. And now I want to simplify this. So remember, when you square a quantity, you've got to square the coefficient and the variable. So you're going to get 4 squared, which is 16. 16 over 2 is 8, so it's 1 minus 8x squared. And now you've got 4 to the fourth over 24. So, we can go ahead. We're going to be using Desmos to check things anyway. So 4 to the fourth divided by 24. You got to cancel a power 4 that'll cancel. And I don't know, this seems recent, but you can actually hit that button and you'll get the 32 thirds. So that'd be plus 32 thirds, x to the fourth, minus, and then you'd have 4 to the 6th over 720. Once again, lots of cancellation there. And we get 256 over 45. X to the 6th. Now once again, I'm only kind of guessing how many terms I need here because I now need to multiply these two series together. Okay. So if I want to get a series for e to the negative x times the cosine of 4x, I need to multiply 1 minus x plus x squared over 2 minus x cubed over 6 plus x to the 4th over 24 times the series for cosine of 4x. Whoops. Okay. So how do you do it? Well, think about when you multiply a quantity times a quantity. Like say I wanted to multiply a plus b plus c times the quantity d plus e plus f. Right? What you've got to do is multiply each term of the first quantity times each term in the second quantity. All the way down the line. Right? Now, you know, there's that when you just have a binomial times a binomial, right? This is the famous, well, it depends where you were raised, I think. You know, it's either you got to make a smiley face. See, there's a smiley face. Or you do that FOIL method, right? Remember the FOIL? Right? The first, the outer, the inner, and then the last. Okay? So it's the same thing. But all this is, folks, is it's a distributive property, right? That's all it is. So look at what we got here. We're going to have to take each term in the first series and multiply it by each term in the second series. And the joke's on us because there's infinitely many terms. Okay? So what the heck? What do we do? Well, remember, they only want the first 4 terms of the answer. Okay? So here's what I like to do. I like to think about the powers of x you can get out from this product. Okay? All right, so this is going to remind you of when we did partial fraction decomposition in the second week of class, where we would equate the like powers. Remember doing that? So let's think about what we're going to get to contribute here. So constants, x to the first powers, x to the second powers, x to the third powers. All right, so let's see. Starting here with the 1, if I multiply it through the second quantity, the only time I'm going to get a constant is when I take the 1 times the 1. So I'm going to have a 1 from that. Once I move to x and I multiply x by everything here, everything's going to have at least an x in it. So my constant term is just going to be 1. Now I move on to the x to the first powers. If I take 1 and multiply it by anything here, I'm never going to get an x to the first power. The smallest thing I'll get is an x squared, so I'm not getting any powers of x from that. So I move to the next term. If I multiply x through by the second quantity, I'm going to have a minus x times 1. That's going to give me a minus x. And at that point, everything else is going to be at least an x squared. Speaking of x squared, let's move to x squared. If I take 1 times anything over here, what's going to produce an x squared? Well, if I take 1 times this minus 8x squared, I'm going to get minus 8x squared that way. Moving on to this minus x. If I take minus x times these terms, am I going to get an x squared out? Well, I'd get an x, and then I would get an x cubed, x to the fifth, etc. So I'm not going to produce any x squared terms from this guy. But if I move on to this term and I take x squared over 2 times the 1, I'm going to pick up another x squared term. And then that would be the last one, because if I start multiplying by the x cubed, I've got something all bigger than x squared. So I go through the arithmetic here. This is what, -8 plus a half. So -7 1/2, -15 halves. You following or not, folks? Do you see where these are coming from? So let's go now. I want x cubes. So I start with 1 and I look at these terms here. Is there any way I can multiply 1 and get an x cubed out of the second piece? Nope. All right, now I move on to the minus x. Can I take minus x times anything here and get an x cubed? Okay, good. What can I multiply by? I'd have the minus x times the what? The minus 8x squared. Good. That's going to give me an x cubed. Let's move on to the x squared over 2. Can you take x squared over 2 times anything and get an x cubed? Nope. Now I move on to the x to the fourth. Can I take x to the fourth times anything here and get an, excuse me. I skipped. Can I take the x cubed over 6 and multiply by anything to get an x cubed? Yeah, you can take the minus x cubed over 6 times what? Times that 1. And then at that point, if I get to the x to the fourth, everything is power 4 or more. So I would get a positive 8x cubed minus x cubed over 6. If I go through the fraction gymnastics there, that would be what, a 47 sixth x cubed. And there's my 1, 2, 3, 4. There's my 4 non-zero terms. Okay. Even though they ask us for the first 4, let's look for x to the fourths. So it's 8. So that's 48 over 6 minus 1 over 6. That's 47 over 6. Okay. Now, even though they didn't ask us to do so, just to make sure we're all good, let's try to figure out where we would get x to the fourths. Let's go through each term here. Can I multiply this 1 by anything over here and get x to the fourth? So let's do x to the fourth even though we don't have to. So if I take 1, can I take 1 times anything over here and get an x to the fourth? Yes, and I'd be multiplying by which term? What term would produce an x to the fourth? 32. Okay, so those match up. Now we move on. Can I multiply minus x times anything over here and produce an x to the fourth? No, because as soon as all these are even powers, so I'm never going to get an x to the fourth out of it. Good. Move on. X squared over 2. Can I multiply any of these things times x squared over 2 and get an x to the fourth? Yes. Which term is going to give me an x to the fourth? The minus 8x squared. So this would be x squared over 2 times a negative 8x squared. How about an x cubed? Can I multiply x cubed by any of these things and get an x to the fourth? Nope. But I can x to the fourth. Oops. And then combining all of these together would give me, whatever x to the fourth. So you see how we're doing this, folks, now? Is that good? Okay, so let's show you how you can check this on Desmos, because remember the theorem. The theorem says if you have a Maclaurin series, I know what the coefficients are. So if we want to check this, remember, given an f of x, the Maclaurin series is f at 0 plus f prime of 0 x plus f double prime of 0 over 2x squared plus f triple prime at 0 over 6x cubed, and so on. So the coefficients of the powers of x, I know what they should be. Okay? So let's go over to Desmos and dial this in. F of x is e to the minus x, cosine of 4x. And let's start with those coefficients. So the first one should be f of 0. Then f prime of 0. F double prime at 0 over 2 factorial. F triple prime at 0 over 3 factorial. And it looks like I goofed here. And we'll change these to fractions. And so my coefficients should be 1, -1, -15/2, 47/6. Boom, 1, -1, -15/2, 47/6. So you see how you can check it with Desmos, folks? All right, so that's multiplication.